In this video, I'll be working through the question you see on the screen here from the summer 2025 Cambridge A-Level Maths paper 1-1. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts as much as you need to. If you are looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. In question 10, they give us two functions, fx and gx, and they want us to describe a sequence of transformations that gets this graph to look like this graph. Now this is it's an interesting question because they haven't shown us images of these graphs. They do actually in the next part, so we could sort of draw one of these, looks something like this, and I happen to know, it's okay if you don't, I happen to know what the square root of x looks like as well. That would look, it starts here and it would look something like that. Now don't worry if you can't do this because it doesn't really help much in the question. I'm just going to use it to describe a few things. Okay, so a step of transformations. When we move things on a picture, they do have a corresponding look in maths. For example, moving something to the left, which is going to have to be moved to the left and down. Moving something to the left is akin to adding something to x. Left is adding, take away is moving to the right. Yeah, that's a confusing way to say it. Going down is somewhat similar, except it's going down is adding to the y part, or going up is taking away from the y part. That might confuse some people because going down is taking away. A lot of people remember, but I'll show you what I mean to the y part in a moment because they're actually quite similar in different ways. Let's go through a transformation here. Y is equal square root of x. What needs to be done? First of all, we need to add something onto the x. So y is equal square root of x plus 2. Okay, we want to get this to look like that. Now, adding something onto the x is the same as moving to the left. That's how I'd write that. You can write that in English if you want, by the way. Move 2 to the left. But to write it in maths term, it's just translating 2 to the left, which is the minus. And next thing I would like to, and I'll show you a few different orders to this in a moment. Next, I'm going to multiply everything by 3. This I would write as stretching, or I just write multiplying. I'll just write down multiply by 3. Stretching by a factor of 3 is how we'd usually write that in English. And actually, let me put them in translation. Apologies if I spelled this wrong. No, stretch. Yeah, apologies if the spelling's wrong. Stretch factor of 3. Next thing, I want to take 5 away. I'll write this twice because just to explain what I was talking about. We added to the x, moved it left. We add to the right, add to the y, moves it down. Equals 3 x plus 2. Although a lot of people just write that as taking away the function. Taking away goes down. I like to think of it as adding goes down because it then keeps it the same as the x. Adding to the x goes the wrong way. Adding to the y goes the wrong way. Left is usually the wrong way. Down is usually the wrong way. That's I would say this last one would be 0 minus 5 is how we'd write that. That's moving downwards by 5. Again, that's a translation. This is full marks if you'd write something like this. But you have other options. You don't have to do it this way. Let me give you a couple of options over here. Actually, first let me write the one we did. We did to translate, the stretch, and the translate again. That was the option I did first. There's other ways to do it. You could have done the stretch first. You could have done multiplied by 3, and then you could have done both of these, like say minus 2 and minus 5. You could have done these in different orders. Hell, you could have even done these at the same time, minus 2 and minus 5. That would have been, all these would be fine answers. The reason this multiply can happen before or after this 2 is because the stretching doesn't worry about the x part. The x happens in here. The y part happens out here. If we multiply this by 3 after I did this 5 part, we'd be in a bit of trouble. And that leads us to the other way we could do it. We could have moved 2 anytime, like I said, before or after. But if we want to move the y part before doing the stretching, we would have had to do something like this, 5 over 3 first, and then stretch. All of these are full marks as an answer. Okay, hopefully I've answered that. If you have follow-up questions, let me know. I'll clean this off and we'll move on to the next part. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part B, they give us a sketch of a GX. Now I have a problem with this question. I'll write what they've given us first. It looks fairly crappy, something like that. It barely looks like a little curve in it. And they want us to sketch the inverse of this. Really what they want you to do, because they even tell you to draw the relevant mirror line. An inverse happens when x and y change place, when x equals y. And when x equals y, that line looks like this. A straight line, a diagonal straight line through the middle. And to sketch the inverse, we just mirror it over here. This would be mirrored over here. The problem with what they drew us is I can barely tell there's a curve. And it's actually a wrong drawing. It's not a really good drawing. I guess it's maybe in their defense it doesn't go all the way to the edge. But that's not a really good defense because their own marking scheme, which this might have confused a lot of students, the answer they have in the marking scheme looks like this. Like this does not look like the drawing they gave you in the exam, whereas this is the correct one. So what they wanted to see, and I'm guessing the students might have been able to complain if they wanted this, what the exam should have done is drawn this line. And then what they wanted to see is this dotted line in the middle and everything being mirrored. Instead of going straight down, this would be mirror up to here, this would mirror up to here. It would look more like a flat line like that. And it would curl like this. This curls away slightly. This curls away. This curls away a lot. That curls away a lot. That's full marks. From what they gave you, I would have just drawn something that seems to curl slightly. Like that's all you can do. You take their drawing and you mirror it. They want this to be roughly the same distance. If you want, what you could do is actually draw a line. Use your ruler, your set square, things like that. Get a few points and just get your compass and put the point over here and get a right angle. And just a few points give you a few places to run off like that. But really a sketch, they just want it done quickly, roughly. They're looking for this center line being diagonal and they're looking for the shape of this to be a mirror of the shape of that. I just think they did a really bad question. I think they drew that really bad. Okay, anyway, hopefully that answers part B. Let me clean it off and we'll do part C. You know, I probably don't need to clean it off. The rest of the questions should be quite quick. C is the only longish one and we have a bit of room here. They want you to find the expression for the inverse of G. Now how I like to do this, let's write G again, but instead of the G I put a Y down. Y is equal to 3 multiplied by x plus 2 minus 5. How you do the inverse is we switch the places of the x and the y. Some people like to do this at the end. I like to do it at the start. It really makes no difference. So if I switch their places, I get x is equal 3 times y plus 2. Square root ends here, minus 5. Now what you need to do is rearrange this so we get y equals. That will be the inverse. You don't have to switch this place, I suppose. It's perfectly fine just to rearrange it and get x equals, and then at the end we rewrite that as the more standard y equals something in x. Okay, so let's rearrange this so y is on its own. First thing, this guy dangling off the end here, let's add it to both sides. We get x plus 5 is equal, yeah, I'll take my time doing this one. We'll be a little careful. I'll do each step. Next thing would be this multiply. That's the next part of the onion to unpeel. He's multiplying this side, so we divide the other side. X plus 5 divided by 3 is equal y plus 2, square root of y plus 2. Next we need to get rid of this square root. We square both sides. So we get x plus 5 over 3 squared is equal y plus 2. Last thing to get rid of is this 2. We take it away from both sides. And I'll write the final answer over here is y is equal x plus 5 over 3 squared take away 2. Sorry, maybe they'd take a mark away from me for that if I leave that as the final answer. What they really want to see is the final answer is, sorry, g of x. The inverse of g of x is equal to that. That's an expression for the inverse of g of x. The next few questions all get 1 mark, so you can answer these straight off the top of your head. I'm going to take a little bit of time to answer part D, so I've cleaned off an extra bit here. Part D is asking us about the range of the inverse of g, the range of this. Just to go back a few steps, let me write gx. The range and the domain. The domain is what can go into gx, and that's what they gave us here. The domain of this is x is bigger than or equal to minus 2. The range of gx, we write that like this. Gx is what answers can get out. And we can see that from our drawing. The only answers that can get out are numbers above here, and this goes off forever. And this number would work out to be actually minus 2. We can see that a little clearer here. The smallest number that can go into this is minus 2. Because this would be 0. 3 times 0 is 0. And then take away 5. Sorry, I said minus 2 over here. This would be minus 5, in fact, my bad. So what will come out of this question, what goes in is everything bigger than minus 2. What comes out of this, it has to be bigger than minus 5. And less than, I'll just write infinity, because you don't have to write that. Bigger than that is fine. That's what goes in and comes out. The inverse is the opposite. The domain of the g becomes the range of the inverse. The range of the g becomes the domain of the inverse. Basically, the answer to part D is simply x is, sorry, not x, the answer to part D is the inverse of x, of g, is just bigger than minus 2. It's because the range of this guy is the domain of that guy. So the g had a domain and a range. The inverse, yeah, let me write it over here. The inverse of this has a domain that's the same as this guy. That'd be x bigger than minus 5. And it has a range that's simply its domain, this one here. So this is bigger than minus 2. I just wrote that to the left, no real reason. Okay, hopefully that's clear. It's the domain and the range just switch places. That's all I wanted to explain there. Okay, I continue to be overconfident on how much I could fit on my board. So let me just rub some of that off and we'll do E. In E, they want us to get the inverse of G of H of 4. They don't write in a bracket here, but I like to put this bracket in because I think it makes it clearer what's happening. What this is actually doing is we're putting something into H, and then the answer from this we're putting into the inverse of G. Let's make that clearer like this. Putting 4 into H is quite easy. Sorry, I never even wrote what H is. Let's do it up the top here. Hx, it was a very simple function. It was equal to x minus 2, and it only worked when x is bigger than or equal to 0. So if I put 4 in, that's simply 4 minus 2, which is simply equal to 2. So instead of the question they gave us, this is why we can do it with just 1 mark. Instead of this is identical to the inverse of g of 2. Instead of h4, it's just 2. h4 is equal to 2. And this is just equal to, I've rubbed off the function, haven't I? I better go to my notes. This is just equal to X, in this case 2, plus 5 over 3 squared minus 2. And that's just 2 plus 5 is 7. 7 over 3 squared, or 7 squared is 49. This is equal to 49. 3 squared is 9. Take away 2. 2 is the same as 18 over 9. So 49 take away 18 is 31. 31 over 9 is the answer to part E. Whenever you get a question like that, just do it in steps. You could have as many letters here as you want, as many of these functions as you want. You could have 5 of them. Just start at the back. Put in your own brackets each time. Yeah, for example, imagine you had f of g of h of k of 3. That's just, you do k of 3, whatever function k is, get that answer, put it into, oh, that was the wrong place, put the bracket, get that answer and put it into h, then get that answer, put it into g, then get that answer, put it into f, and that's your final answer. It's actually quite a simple steps to do to answer this. Okay, for the final mark in this whole paper, they want you to explain why the composite function h of the inverse of g, opposite of this, why that doesn't work. H inverse g of x. Why does this, why can it not be formed? The answer comes down to its domains and its ranges. What comes out of this g1 is what, the inverse of g is what goes into h. And to go back to my example here, what came out of the k went into the h. What came out of the h went into the g. What came out of the g went into the f. What came out of the h went into the inverse g. What came out of the inverse g goes into the h. So we're talking domains and ranges here. What came out of the inverse g is its range, and that's, you just found that out over here. The range of gx, what comes out of that, is bigger than or equal to minus 2. All of this comes out of that. What's allowed to go into h is bigger than 0. That's a problem. They don't match. We cannot do this function because sometimes we will get minus 1 coming out of this inverse g. And minus 1 can't go into h. We're not allowed. So you could make a composite function of two functions that were nearly like this. If you made sure, if you told inverse of g, just be careful never to give me something less than 0, then you'd be fine. But you can't do that. To get a function of these two can't happen because you don't trust. You don't trust the inverse of g not to send out something that h will go haywire. Think of these as machines, a few machines in a row. You have to trust the previous machine won't break the next machine, and that's what happens here. It breaks the next machine. What do you write as the answer? The range of inverse g is not compatible with the domain of h. That'd be full marks there. Okay, that's it for question 10 and this whole paper. If you have any follow-up questions or anything you want to say in the comments, put them in the comments and I'll do my best to get back to you. Thanks for watching and have a great day.